Hey, good morning, everybody. Did y'all have a good weekend? Yeah. Yeah, maybe. So. All right. So here we are in the last week of class. Um, Today we want to talk about assignment 26, determinants and Kramer's rule. I'll just kind of get a little inquiry about that here in a moment. But I just want to start off with just a couple of quick thoughts that are on my head. Number one, this is the only new assignment that we're going to tackle this week. Determinants and Kramer's rule, where you're not going to tackle the binomial theorem, and it will not be on the final exam. So what we'll do is we'll spend Wednesday and Friday this week doing any sort of review that you want to do. As I said, you had the review to the final exam. You had the previous exams and quizzes and homeworks to look at. Anything that we talked about this semester can be on the final exam. And that final exam is, make sure I get this right, is on Wednesday of next week, correct? Yes? Wednesday, 8 o'clock? Alright. I gotta flush Monday out of my mind. I keep thinking Monday. Wednesday at 8 o'clock next week. Alright. I know I've talked about a quiz, for last week, and I just don't have one yet. So maybe we do one. Maybe we do two quizzes this week. I don't know. If we don't do any quizzes, that's okay. You will have a homework set due. You'll have one due on Sunday, and you will have stuff due for determinants and Kramer's rule. All right, so question. Have we done the notes for assignment 26? Yes or no?
We've all done the notes but haven't started the assignment yet.
Okay. And I see there's another school that thumbs down, haven't done the notes. Have not done the notes. All right. So I was thinking about this morning. We're just going to I'm just going to do some examples of determinants and Kramer's rule, and for those of y'all, I'm going to do some examples first, and then if you encounter any questions on your homework, we can cover those. So let's just look at some thoughts about assignment 26. All right, so the first thing that we want to do is, let's just call this goal number one, is to find the, because I don't like writing out determinant, DET, that is shorthand for of a 2x2 system. Now, if you take any higher level mathematics courses, you're going to talk more about what determinants can do for us. especially if you take any sort of computer science course. But we're not going to get that deep. We're just going to play around with them and then use them in Cramer's rule. So let's just take a quick look at an example. Again, these do not align with the notes. Suppose that you have the system negative 2x plus 6y equal to 4, and we had the next equation, 5x plus y is equal to 6. So here's your system. So the first thing that we want to do is we want to get it into the augmented matrix. So in terms of the augmented matrix, this looks like the following. Negative 2, 6 equals 4, and 5, 1 equals 6. Okay, so the next thing that we want to do is we want to find the determinant of the coefficient matrix. Alright, so going back up to your system, the coefficients are the numbers in front of your x and y. So if we're going to find the determinant of a coefficient matrix, the coefficients are the negative 2, 6, 5, 1, and we have some very specific symbols that we use for finding the determinant. In fact, the symbols that we use are, instead of using brackets, we use these vertical bars, kind of like absolute value bars, around our coefficient matrix. So for this problem, if I put absolute value bars around the coefficients, this is your symbol notation to find the determinant. And how do you find the determinant of a matrix? Well, this is where I like my colors. They come in very handy. It's a very, very simple set of operations. Very simple set of operations. So the first thing that you're going to do is you're going to multiply down this diagonal. So that's going to become a negative 2 times 1 and then you are going to subtract the product of this diagonal. So that becomes minus a 6 times a 5. That is how you find the determinant of a 2 by 2 matrix. So now all you got to do is just do the math. So the math is going to become a negative 2 minus 30, which that equals a negative 32. And that, ladies and gentlemen, is how you find the determinant of a 2 by 2 matrix. It's that simple. It's that simple. So let's do one more example, then we'll move on to a 3 by 3. So example 2. Suppose I had the system 2x plus 3y is equal to a negative 12, and then negative 6x minus 2y is equal to 7. Well, the first thing I'm going to do is I'm going to get it into the augmented matrix. 2, 3, negative 12. Then we have negative 6, negative 2, 7. And if I want to find the determinant of the coefficient matrix, so we often we'll just say, determinant of the coefficient matrix, we're just going to write this out. Again, think about those absolute value bars. And so, again, here's your operation. You're going to multiply down that diagonal, so that's going to be in blue. So that's going to be 2 times the
Mr.
negative
Compton,
2. Yes, ma'am?
we can't see your screen.
Oh, yeah, I need to move that up a little bit. Sorry about that. So we take 2 times a negative 2, and then you multiply down this diagonal. Now this is just the way I do it. I go this way and this way. It doesn't matter. I mean, you could multiply it this way. It's still going to be the same product. But make sure that you subtract minus 3 times a negative 6. And then all we have to do now is just do the math. Do the math. So what do we have? We have a negative 4 minus a negative 18. So that's going to be the same thing as negative 4 plus 18, which is going to be equal to a 14. And that's how you find the determinant of a 2 by 2 matrix. Okay, so let's move on to finding the determinant of a 3 by 3 matrix. So goal 2. Find the determinant of a 3 by 3 matrix. So let's just go right into the coefficient matrix. Suppose you have the augmented matrix that looks like, let's do this. Negative 4, negative 2, negative 1 equals negative 11. Then we have negative 1, negative 2, 0, negative 6, and then 1, negative 1, negative 5, 5. Let's suppose that we had the system and its augmented matrix that gets transcribed into this, and we want to find the determinant of our coefficient matrix. So what are our coefficients? Our coefficients are, we have negative 4, negative 2, negative 1, negative 1, negative 2, 0, 1, negative 1, negative 5, and there's our absolute value bars. Now, there's 2 ways to do this. There's one way to find this that's basically in every single textbook, and then there's a second way, a more simple way to find this, which is kind of not in every single textbook. And so I'm just going to show you the simplest way to do this. And the nice thing about this very simple way to do this is it's very reminiscent of this pattern that we had over here for our 2 by 2 matrices. So this is something that I learned in college. A lot of our other instructors teach this, and I think we all call this, if you want to look this up, we call this the basket weaving. We call this basket weaving. So here's what we're going to do. We're going to continue this coefficient matrix by repeating the first two columns. So, just kind of showing you what I'm about to do, we're going to put the first two columns, we're just going to repeat them. So you got -4, -1, 1, and then -2, -2, -1. So that's the first step. Repeat those first two columns. If you want to, go ahead and put a line right there. And now, what we're going to do is we're going to need to make some diagonals. Now, this is why I like to use my colors. Notice that the blue diagonal that I had went down from left to right. That was my blue diagonal. Well, going back over here to my 3x3 matrix, we have this diagonal, we have this diagonal, and we have this diagonal. There are three diagonals that go from left to right. And then, again, looking back at our example in the 2x2 matrix, my red arrow, my red diagonal went from right to left, going down. So, going back to my 3x3 matrix, there are three diagonals that go from right to left. 1, 2, 3. Now, all the blue diagonals get added together. Blue means that you're adding the diagonals together. We're still going to be multiplying down the diagonal, but we add. So what do we have? We have -4 times a -2 times a -5 plus a -2 times 0 times a 1 plus a -1 times a -1 times another -1. So that we can all see this. Then we're going to subtract. So notice how I'm adding the diagonals together. I'm not adding these numbers. When I say a diagonal is multiplying down the diagonal. But we're adding the blue diagonals together. Then we're going to subtract these diagonals. And so I just go from right to left. So -2, -1, -5. Minus -4, 0, -1, minus -1, -2, 1. Okay, so now we got to do some math. Here's the math. Alright, so -4 times a -2 is a -8, or excuse me, +8 times a -5 is a +40. Now, I love it when I have a 0 as an element, because I know that -2 times 0 times 1 is just going to be 0. Then you got -1 times -1 times -1, that's a -1, so plus a -1. Then we have minus, here we go, -2 times a -1 times a -5, so that's +2 times a -5 is a -10, minus 0, because we got a 0 right there, minus -1 times -2 is a +2 times 1 minus 2. So, if you need to, you can simplify this a little bit. Come on, iPad. Maybe it's time to get a new iPad. I don't know. There we go. This becomes 40. Who cares about that? Minus 1 plus 10 minus 2. So 40 minus 1 is 39, plus 10 is 49, minus 2 is what did I say? 40 minus 1 is 39, 48. 40 minus 1 is 39, plus 10 is 49, minus 2 is a 47. Yeah. And that's how you find a determinant of a 3 by 3 matrix. All right. We're going to get some more examples with doing 3 by 3 matrices, because I got things to talk about. So we now know how to find the determinants of 2 by 2 and 3 by 3 matrices. So let's apply that to Cramer's rule. Cramer's rule is how you can solve a system with determinants. So let's go back and take a look at this system right here. There's that system. This is from, what example was that? That was example 1. Alright. From example 1. Here's what we need to do in order to solve this system using Cramer's rule. We need to find the determinant find the determinant of our coefficients. Now we've already done that. That's going to be the determinant -2, 6, 5, 1. And we already know that to be equal to, well, I can just do real quickly, that's -2 minus 30, that's a -32. Is that what we got? Yes, -32. Now, we're going to call this determinant capital D. We are going to call that determinant capital D. The next determinant that we have to find is we have to find D sub x. Now, this is how you find D sub x. What we're going to do is we are going to replace the coefficients of x with the constants. Now, let's just take a look back at the original system. The original system, the constants were the 4 and the 6, what the equation equals. There's your 4 and a 6. And what we're going to do is we're going to replace this column of the coefficients of my x's with the column of my constants. So going back and looking at d sub x is going to be equal to, so take a look at your x's, that's -2, 5. You're going to replace -2, 5 with 4, 6. That's your constants, and then your y's stay the exact same, 6, 1. And we go through the exact same math. We're going to multiply down that diagonal, we're going to multiply down this diagonal, and work it out. So here we go. 4 times 1 is 4, minus 6 times 6 is a 36. So we have 4 minus 36, that's going to be equal to a negative 32. This is, again, d sub x. Maybe I should be circling these rather than highlighting them. So let me just circle that. We'll just leave it boxed in. So we have d sub x. The next thing that we need to do is we need to find d sub y. So it's going to operate just the same way as finding d sub x. We're going to replace the coefficients of y with the constants. That's how you find d sub y. So d sub y, so again, using the absolute value bars is the mathematical symbols that we use to indicate that we're finding the determinant. So look back up here. We're going to replace this 6, 1 with the 4, 6. So we have still the same coefficients for x, negative 2, 5, but we replace 6, 1 with 4, 6. And again, we go through and we find the determinant. Multiply down this diagonal, multiply down that diagonal. What do we get? Negative 2 times 6 is a negative 12. This equals a negative 12 minus 4 times 5 is 20. So negative 12 minus 20 is equal to a negative 32. And this is d sub y. Okay. Now here's where Cramer's rule comes into place. Cramer's rule says that x is equal to d sub x over d, and y is equal to d sub y over d. That's what Cramer's rule says. Cramer's rule says that if you want to know the value of x and y, just take the determinant of x divided by d, and to find y, take the determinant d sub y and divide it by d. So here we go. X is going to be equal to d sub x over d. So what was d sub x? It was a negative 32. What was d? D was also negative 32. So that means, which is 1, so that means that x is equal to 1. And y is equal to d sub y over d. So that is equal to a negative 32 over a negative 32, which is also equal to 1. So that means that y is equal to 1. So our solution to this system in terms of x and y is 1, 1. And that's Cramer's rule. Now, for a 2 by 2 system, I probably wouldn't use Cramer's rule to solve, but it's a nice little way to start recognizing how this is going to work for a 3 by 3 system. Let's do a quick check. So think about, here's our check. So that's a negative 2 times 1 plus 6 times a 1. So that's going to equal negative 2 plus 6, or 6 minus 2 is equal to 4. Check. And then our next system, 5, 1, 5 times 1 plus 1 times 1, 5 plus 1 is 6. Check. And that's how we find we use Cramer's rule to solve a 2x2 system. So let's do this one more time. We'll continue to use examples that we've already looked at. Here we go. Let's use this example down here. Alright. So going back to example 2. We have already found the determinant of the coefficient matrix. And so that makes this D. That's our determinant of our coefficient matrix. So now we need to go through and find D sub x and D sub y. So here we go. D sub x, again, you replace the column of your x's, the coefficients of your x's, with the column of your constants. So D sub x is going to be equal to the determinant of, I'm going to list this off by columns now, negative 12, 7, and then 3, 2. Alright, so we're just going to go straight to the math. Remember, you're multiplying down the diagonal, so negative 12 times 2 is a negative 24.
Mr. Clopton, I think the 2 on the bottom right is negative.
Thank you. It is negative. Got to be careful about that. Thank you. That is correct. So that's going to become a positive 24 minus the 3 times 7, so that's going to be minus 21. So 24 minus 21 is going to be a 3. So here is D sub x. And then we have to find D sub y. So in this case, you replace the column of your y's with your constants. So listing things out by columns, we have 2, negative 6, and then negative 12, 7. So here's the math. 2 times 7 is going to be a 14 minus negative 12 times a negative 6, so that's going to be a positive 72. 14 minus 72 is going to be a negative 58. And this is D sub y. So, by Cramer's rule, says that x is equal to D sub x over D, y is equal to D sub y over D. So here we go. D sub x is 3. D is 14. Now, I'm looking at that, and I'm going to ask myself, does this simplify? The answer is no. So we just declare that x is equal to 3/14. And then D sub y is a negative 58 over 14. Does this simplify? Yes. Both 58 and 14 are divisible by 2, so this means that y is equal to a negative 29/7. Now, don't be detoured by the fact that we got some fractional answers here. I would dare say that we probably get more fractions using Cramer's rule than we do just for solving a regular system. So how are we going to check this? Well, I just like to use my calculator here. So, in my calculator, I'm gonna try to get this where y'all can see this without glaring. Um, Let me just type this in. I need to do 2 times the 3/14. So in my calculator, I'm gonna do 2, open parentheses, 3 divided by 14, close parentheses. And then we have plus 3y, so that's going to be plus 3, open parentheses, y is a negative 29/7, so negative 29/7. I'm going to hit enter, and look what we get. We get negative 12 exactly what we have right up here. And then I'm going to check it with my second equation. So I just go back up, and I'm just going to change my coefficients to a, I need to delete, insert a negative 6. So we have negative 6 times the 3/14, and then we have minus 2, so I can do just minus 2, hit enter, and look, we get 7. Exactly what we have right here. And that's Cramer's rule. That's how we can use Cramer's rule to solve 2x2 systems. So let's go back to our 3x3 system and use Cramer's rule to solve it. So we already have, so we're just going back over here to this page. We're now going to use Cramer's rule to solve. Alright, so what do we need? We need D, which we already got. There's D right there. We need D sub x, we need D sub y, and we need D sub z. Because Cramer's rule says that x is going to be equal to D sub x over D, y is going to be equal to D sub y over D, and z is going to be equal to D sub z over D. And, this is why we did those 2x2s, because now it's going to be really quick and easy to find these other matrices. So, looking at this matrix right here, D sub x, we're going to replace the column of our constants, or of our x's, with the column of our constants. So, listing this out in columns, we have negative 6, negative 11, negative 6, 5. So we're replacing this column with our constants. Then we repeat negative 2, negative 2, negative 1, negative 1, 0, 5. And then by the basket weaving method, we're going to repeat the first 2 columns.
That one's negative 5.
Thank you.
You're welcome.
Repeat the first 2 columns, so that's going to be, again, by columns, negative 6, negative 11, negative 6, 5, negative 2, negative 2, negative 1, and here we go. So I'm going to just draw out our diagonals so that we can see them. Drawing out my diagonals really helps me see what I'm multiplying, because as you can see, even leading by example, it's really easy to write something down wrong, or it will be even easier to multiply things incorrectly. So here we go. Alright, so oftentimes I just look down the diagonal at my signs. I have a negative times a negative times a negative. So I know that this is going to be equal to a negative. I think 5 times 2 is easy. 5 times 2 is 10, times 11, that's going to be a negative 110. Love having that 0 right there, plus 0. Then a negative times a negative times a negative is negative. So 1 times 6 times 1 is going to be, that's going to come out to be a negative 6. Now, going down this way, I'm just going to go ahead and put my negative in place. That way I don't have to think about it. 3 negatives makes a negative. 2 times 5 is 10. Times a 6 is going to be 60, so that's going to be negative 60 minus 0. It's got a 0 right there. Minus, we have 2 negatives, so that becomes a positive. 5 times 2 is 10, times 1 is 10, so minus 10. So what do we get? I'll just simplify this as I go. Negative 110 plus 0 minus 6, that's going to be a negative 116. Plus 60 minus 10. So that's going to be a negative 116 plus 50. And then that's going to be equal to a 66 negative, because 50 plus 50 is 100. Then you got to get to 16, so 50 plus 16 is 66, so that's going to be a negative 66. There is our d sub x. And I can already tell you that something is wrong. Something is wrong. Because I'm looking at what the answer should be. And I can tell you right now, looking at this, that's not correct. So let's do a couple of checking our math real quick. This is where you want to go. Make sure that, let's double check our determinant of our coefficient matrix first. 4, negative 2, negative 1, negative 1, negative 2, 0, negative 6, 1, negative 1, negative 5, 5. So that's going to become a there it is right there. I see one error right off the bat. You have a, back over here in our determinant matrix, negative 4 times a negative 2 times a negative 5. That should be a negative 40. That should be a negative 40. So, negative 41. Negative 43. That becomes a negative 30. That becomes a negative 33. Yes. All right. So we have an error, ladies and gentlemen. We need to go back all the way up. So we're at our 3 by 3 matrix. That should have been a negative 40. Because negative 4 times a negative 2 times a negative 5 is a negative 40. Then negative 40 minus 1 is a negative 41. Minus 2 is a negative 43. Plus 10, that becomes a negative 33. Now, I'm looking at the answer, and I know that this is going to work out this so far. So far, we're good. There's d sub x. The next thing that we have to go through and do is find d sub y. Alright, so what are we going to do to find d sub y? we're going to replace the column of our y's with our constants. So the x's stay the same. So -4, -1, 1. Our y's become -11, -6, 5. Our z's stay the same, so that's the -1, 0, -5. And then what do? In basket weaving, we repeat the first two columns, -4, -1, pencil, did you? -4, -1, 1. -11, -6, 5. And here we go. Now again, for the purposes of just keeping everything in line, here we go. -4 times, so we got 3 negatives, so that's going to be minus. 4 times 5 is 20, times 6, that's going to be a -120, plus 0. Oh man, my pencil. Alright. As you can see right here, the battery on my pencil is dead, so I apologize about that. So, I can tell you, what the answer should be. For this system, after you go through and find d sub y and d sub z, and you do dx over d, dy over d, and dz over d, x, y, and z should equal 2, 2, -1. So x is 2, y is 2, z is going to be -1. And I'll let you go through and verify that for yourself. So, for those of y'all that hadn't started the notes yet, there was a quick look at solving 2x2 and 3x3 systems using Cramer's rule. You have the lecture notes videos that I provided to you on Blackboard. So where does this put us?
Your conference is scheduled to end in 2 minutes.
Thank you. Where does this put us for the rest of the week? Wednesday, come in. I hope that on Wednesday that you have tackled this assignment. If there's any lingering questions over assignment 26, we'll tackle them on Wednesday. If there's not any lingering questions, we're going to go straight into reviewing for the final exam. Now, I said this last week, and I'm going to say it again. I am answering your questions for review. If you don't bring any questions to the table, then it's a waste of time, and I'll just dismiss class. I'm not going to sit up here and just on my own go through and talk about what you need to know. You have the review, you have your exams, you have your quizzes, you have all the homework. So bring your questions to the table. This is your time to ask questions. So it is up to you to make the most out of our time for review on Wednesday and Friday of this week. So, bring any questions over assignment 26 to the beginning of class on Wednesday. We'll address those, and then we'll begin a review. So y'all have a wonderful rest of your day, and I will see y'all on Wednesday. Take care. Bye-bye.
Your conference is now over. Goodbye.
It's okay to have fun every now and then. Bye.